Hi, this next video is going to be about right triangle trigonometry application questions. The directions say, draw a picture to help visualize the situation, then solve. If necessary, round your answers, final answers to the nearest tenth. And so in this scenario, question number 7 says, a surveyor measuring the tallest tree in the park is 100 feet from the tree. And so we're first going to draw a figure, and so we have a tree, right, in the park, and we have a surveyor, and so we're going to have a person, and we're told that the surveyor is 100 feet from the tree, and it says his angle measuring device is 5 feet above the ground, and so he has a tool that he uses to measure the angle. And so that has a height of 5 feet. And again, the person is 100 feet from the tree. The angle of elevation to the top of the tree is 48 degrees. And so the angle of elevation is from the person looking up from his device to the top of the tree. And so his angle of elevation is 58 degrees. And it's asking us to find how tall is the tree. And so in our diagram, we have a right triangle. And so we have our reference angle of 58 degrees. We have the adjacent side. And we're looking for how tall the tree is. And so that's the vertical length, which is x. And so using our right triangle trigonometry, we have the opposite side, which is unknown, the adjacent side of 100, and so we can use the tangent function. So the tangent of an angle is again equivalent to the opposite over adjacent. And so if we substitute in what we know that, or we have the tangent function. Our reference angle is 58 degrees. The opposite side is unknown, so that's x. And the adjacent side was 100. So in order to solve an equation, here we have our fraction. And so in order to undo the fraction, we're going to multiply by the denominator. So multiply both sides by 100. So dividing by 100 and multiplying by 100 cancel each other out. And so we have 100 times the tangent of 58, and that is equivalent to x. So now that x is by itself, we can use our calculator and enter that information in. So 100 times the tangent of 58 degrees is equivalent to 160.0335 if we go to 4 decimal places. And so if we write that down in our notes, we have x was equal to 160.0335, I do believe. So let's just double check that once. 160.0335. Okay. So now that is the length of the opposite side in our triangle. However, notice we're trying to find the height of the tree, and so there's a gap between the ground and our tree. That gap was 5 feet long. So in order to find the height of the tree, we have to add the height of the surveyor's angle measuring device, and so if we add 5, we'd have 165.0335. And so in our in the directions it asks us to round our answer to the nearest tenth. So the height of the tree in this scenario is 165 rounding to the nearest tenth, 0, and our label would be feet. Now, the second example, taking a look at the scenario, it says 20 minutes after being launched, a hot air balloon has risen to an altitude of 300 meters. So we have the ground, we have a hot air balloon, and we know that that has risen vertically 300 meters. Additionally, the pilot can still see the starting point on the ground at an angle of depression of 25 degrees. And so the pilot, being in the balloon, right, if he looks straight out, this is his line of sight, but he's looking down at an angle of 25 degrees, and so we have an angle of 25 degrees on the outside of our triangle. And he can see the starting point from where he launched. Now, because this angle is outside of our triangle, we have to use parallel lines. So the pilot's line of sight and the ground are parallel. And so the angle of depression and the angle of elevation are alternate interior angles. And so we'd have a 25-degree angle for the angle of elevation. Now, in this scenario, the question is asking us to find how many meters is the balloon from the starting point. And so here's our balloon to our starting point down on the ground. So if we want to calculate that distance, we can label that as x. And so using our reference angle, we have a reference angle of 25 degrees. The 300 meters is across from that, so that is the opposite side. And the unknown distance is across from the right angle. That is our hypotenuse. So using opposite and hypotenuse, we know that is the sine function. So the sine of our reference angle is equal to the opposite over the hypotenuse. And so if we substitute in what we know, the reference angle is 25 degrees. The opposite side is 300, and the hypotenuse is unknown, x. Now in order to solve our equation, multiply by the denominator. So multiplying by x and dividing by x cancel each other out. So we have x times the sine of 25 equals 300. Now, x is still not by itself, so to undo multiplication, we can divide by the sine of 25. And so multiplying by sine of 25 and dividing by sine of 25 cancels each other out. And so we have x alone is equal to the 300 divided by the sine of 25. And so we can now enter that information into our calculator. 300 divided by the sine of 25 is equivalent to 709.9, because again it asks us to round to the nearest tenth for our final answer, so 709.9 meters. So our final answer, the distance from the balloon to the starting point, 709.9 meters. Thank you for watching.